Welcome to Astronomy Daily, your go-to source for the latest news from space and beyond. I'm Anna.
And I'm Avery. We've got some absolutely fascinating stories for you today. From groundbreaking research on how space travel affects our bodies, to a spectacular lunar eclipse coming next year, and even the most expensive Lego set ever created.
Oh, that Lego story is going to be fun. But first, let's dive into some serious science. NASA just published some pretty concerning findings about what happens to our blood cells in space. Avery, this study tracked human stem cells during 4 different SpaceX missions to the International Space Station.
Yeah, and the results are pretty eye-opening, Anna. These cells spent between 32 to 45 days in space, and researchers found they started losing their ability to make healthy new cells. Basically, they began showing signs of accelerated aging up there.
That's really troubling when you think about it. What specifically were they seeing? DNA damage?
Exactly. The cells show DNA damage and something called shorter telomeres. Think of telomeres like the plastic tips on shoelaces. They protect our chromosomes, and when they get shorter, it's a sign of cellular aging. But here's the interesting part. Some of this damage actually reversed when the cells returned to Earth.
That's actually encouraging news. So our bodies might have some ability to recover from space-induced aging. But this research is crucial for planning those long-duration missions to Mars, right?
Absolutely. A trip to Mars could take 6 to 9 months each way, so we're talking about astronauts spending well over a year in space. Understanding how to protect them from the cellular damage is going to be essential. The research team, led by scientists from UC San Diego, found that the space environment creates what they call a senescence-like state in these stem cells, basically premature aging at the cellular level. Plus, this research might also help us understand aging here on Earth, potentially leading to new treatments for age-related diseases.
That's fascinating. So what exactly is it about the space environment that causes this damage? Is it the radiation or the microgravity or both?
Great question, Anna. It's actually a combination of multiple stressors. First, there's the cosmic radiation, high-energy particles that constantly bombard astronauts outside Earth's protective magnetosphere. Then there's microgravity, which affects how cells distribute nutrients and waste products. The researchers also noted that the confined space environment and altered circadian rhythms could contribute to cellular stress. It's like a perfect storm of conditions that our bodies simply didn't evolve to handle.
Are there any potential countermeasures being developed? I imagine this research is leading to ideas about how we might protect astronauts on those long Mars missions.
Absolutely. NASA and other space agencies are exploring several approaches. They're looking at pharmaceutical interventions, drugs that could protect cells from radiation damage or help maintain telomere length. There's also research into better spacecraft shielding, artificial gravity systems using rotating modules, and even the possibility of using stem cell therapy to refresh an astronaut's blood supply during long missions. Some scientists are even investigating whether certain dietary supplements or exercise regimens might help counteract these effects.
That's a great point. Space research often leads to medical breakthroughs for everyone. Speaking of things we can all look forward to, let's talk about this amazing lunar eclipse coming up. Avery, tell me about this blood moon event.
Oh, this is going to be spectacular. On September 7th and 8th, 2025, we're getting a total lunar eclipse that will be visible to over 7 billion people around the world. That's like 85% of the global population, Anna. The eclipse will be best seen from Europe, Africa, Asia, and Australia. The total phase will last for about 65 minutes, making it one of the longer total lunar eclipses we'll see this decade.
That's a long duration. Can you walk us through what viewers will actually see during those 65 minutes of totality?
It's going to be amazing. The eclipse will begin with a subtle dimming as Earth's penumbral shadow starts covering the moon. Then, around 1826 UTC, the partial eclipse begins as Earth's darker umbral shadow starts taking a bite out of the moon. The real magic happens at 1930 UTC when the moon will turn that beautiful deep red or copper color. During totality, viewers might also see stars that are normally washed out by the moon's brightness. The whole event will last about 5.5 hours from start to finish.
Wow, that's incredible reach. But unfortunately, we here in the US won't be able to see it directly, right?
That's right, but don't worry. There are going to be multiple free live streams available. The Virtual Telescope project in Italy and Time and Date from Cyprus are both planning coverage, so we can still experience that beautiful blood moon effect from our computers.
For our listeners who might not know, can you explain what creates that dramatic red color during a total lunar eclipse?
Sure. So during a total lunar eclipse, Earth passes directly between the moon and the sun. But Earth's atmosphere acts like a lens, bending sunlight around our planet. The red wavelengths of light get through more easily than blue ones, so the moon takes on this eerie reddish glow. It's the same reason sunsets look red.
I love how astronomy connects these everyday phenomena. Now, let's shift gears to some exciting telescope news. The Murchison Widefield Array in Western Australia just completed a major upgrade.
This upgrade is massive, Anna. They've completed what they're calling Phase 3, which doubled the telescope from 4,096 antennas to 8,192 antennas spread over a 30 square kilometer area. That's quadrupled their data output and significantly improved their resolution.
That's an incredible scale. What are they planning to study with all this new capability?
They're focusing on some of the most fundamental questions in astronomy. They want to study the epoch of reionization, basically the period when the first stars and galaxies lit up the universe after the Dark Ages, about 13 billion years ago. This upgrade will let them map hydrogen signals from that era with unprecedented detail. They're also looking at transient events like fast radio bursts and something really mysterious called odd radio circles, or ORCs. Plus, they'll be doing advanced studies of pulsars, which are like cosmic lighthouses that can help us understand extreme physics.
Odd radio circles. That sounds intriguing. Are these like crop circles, but in space?
Not quite, but they are mysterious. ORCs are these huge circular radio structures that we can see with radio telescopes, but they don't appear in visible light, X-rays, or infrared. We're not exactly sure what causes them. They might be shockwaves from galactic collisions or something even more exotic. The upgraded MWA should help us figure out what they really are.
And this is all preparation for an even bigger project, right?
Exactly. This upgrade is helping prepare for the Square Kilometer Array, or SKA, which will eventually have 131,000 antennas. When that's complete, it'll be the world's largest radio telescope. The MWA is basically a testing ground for the technologies and techniques they'll need for that massive project.
Speaking of groundbreaking discoveries, we should talk about some recent James Webb Telescope findings that are literally rewriting astronomy textbooks. Avery, the Webb Telescope has been finding galaxies that are much more massive and mature than we expected in the early universe.
Oh yes, this is absolutely revolutionary stuff, Anna. Webb is seeing galaxies that formed just 400 to 600 million years after the Big Bang. That's when the universe was only about 3 to 4% of its current age. But these galaxies are surprisingly large and well-structured. Some are as massive as our Milky Way, which, according to our previous models, shouldn't have been possible so early in cosmic history. It's like finding a fully grown oak tree in what you expected to be a nursery of seedlings.
That's such a perfect analogy. So, what does this mean for our understanding of how the universe evolved? Are astronomers having to revise their models?
Absolutely they are. These discoveries suggest that galaxy formation and growth happened much faster than we thought possible. Astronomers are now reconsidering how efficiently the first black holes and stars formed, and how quickly they could accumulate matter. Some theories propose that the universe's early dark matter structures were more massive and formed more rapidly than our standard models predicted. It's also possible that the first stars were much more massive and short-lived than we assumed, leading to faster chemical enrichment of the early universe.
It's incredible how much Webb is changing our perspective on the cosmos. And speaking of discoveries that challenge our assumptions, let's talk about some exciting news from Mars. The Perseverance rover has made some remarkable discoveries in Jezero Crater that are giving us new insights into ancient Martian water activity.
Yes, this is really exciting. Perseverance has been analyzing sedimentary rocks that clearly show evidence of a substantial lake that existed in Jezero Crater billions of years ago. But what's particularly interesting is the chemistry they're finding. The rover has detected organic compounds, carbon-based molecules that could potentially be biosignatures. Now, these could also have non-biological origins, but they're exactly the kind of molecules that life as we know it would produce.
And Perseverance is collecting samples from these promising locations, right, for eventual return to Earth?
Exactly. Perseverance has now collected over 24 samples in sealed tubes, and several of them are from these particularly intriguing locations. The Mars sample return mission is still being planned, but when those samples eventually make it back to Earth, hopefully sometime in the 2030s, scientists will be able to analyze them with laboratory instruments that are far more sophisticated than anything we can send to Mars. That's when we might finally get definitive answers about whether life ever existed on Mars.
The possibility of finding life on Mars, that would be the ultimate discovery. But while we wait for those samples to return, let's bring things back to Earth with something that's sure to delight space fans of all ages. And it's going to cost you nearly $1,000 if you want it.
Oh, you're talking about the new LEGO Death Star. Anna, this thing is absolutely incredible. LEGO just announced their new Star Wars Ultimate Collector Series Death Star, and it's the most expensive LEGO set they've ever made at $999.99.
Nearly $1,000 for Lego blocks. But I have to admit, when I saw the specs, I was pretty impressed. How many pieces are we talking about here?
Get this, 9,023 pieces and 38 minifigures. The completed Death Star measures 28 inches high, 32 inches wide, and 11 inches deep. It's got this amazing cross-sectional design that shows all the famous locations from the Star Wars films inside the Death Star.
So you can see the throne room where Luke confronted the Emperor, the trash compactor, all those iconic scenes.
Exactly. And LEGO really knows their audience. It goes on sale October 1st for LEGO insiders, and then everyone else can get it starting October 4th. What's really impressive is that this isn't just a display model. It's designed to be highly interactive. The cross-sectional design lets builders recreate famous scenes from the movies, and with 38 minifigures, you can populate all those detailed interior spaces. I have a feeling this is going to sell out pretty quickly, especially with the holidays coming up.
The engineering that goes into these massive Lego sets is incredible too. I imagine supporting a structure that size and weight with Lego bricks requires some serious architectural planning.
Oh, absolutely. LEGO's designers are basically architects and engineers. This Death Star uses advanced building techniques like Technic beams for internal structure, specialized connector pieces to handle the weight distribution, and clever use of overlapping plates to ensure stability. The fact that it can support its own weight while still allowing access to all those detailed interior sections is really a masterpiece of toy engineering. It's estimated to take about 20 to 30 hours to complete for most builders.
I can see this becoming a serious collector's item. Though at that price point, it's definitely more of an investment piece than a casual purchase. But for Star Wars fans who also love building, it sounds like it could be worth every penny.
Absolutely. And you know what I love about stories like this? It shows how space and science fiction continue to inspire people in so many different ways. From serious research about aging in space to incredibly detailed recreations of imaginary space stations.
That's such a great point, Avery. Whether it's NASA studying how to keep astronauts healthy on Mars missions, radio telescopes peering back to the dawn of time, or LEGO bringing the Death Star to our living rooms, it all stems from that same human fascination with what's out there beyond our world.
And we'll be here to bring you all of it. That's all for today's episode of Astronomy Daily. Don't forget to mark your calendars for that lunar eclipse in September 2025. Even if we can't see it directly here in the US, those live streams are going to be amazing.
Thanks for joining us today, everyone. Keep looking up, and Steve and Hallie will be here on Monday with more news from the cosmos. I'm Anna.
And I'm Avery. Until next time, stay curious about the universe around us.